What if I told you that the skeleton inside you outperforms concrete in several ways? It might sound like a joke, but it's true. Your bones are stronger than concrete. Today we'll show how your bones are built to be light, flexible, and unbelievably strong. In compression tests, concrete can handle a heavy load, but it shatters under tension. Bones are composite structures that combine strength and flexibility. They bend before they break. Unlike concrete, which is brittle and cracks suddenly, our bones are designed to withstand the dynamic forces of everyday life. But why is that? It's because bone is not just solid rock. The outer shell, called cortical bone, is incredibly dense and hard. But inside, there's a honeycomb-like structure called trabecular bone. That spongy architecture is a masterpiece of natural engineering, providing immense strength with minimal weight. This internal design is key to how our bodies can move so efficiently. When you look at it pound for pound, bone is actually stronger than concrete. Engineers use a measurement called the strength-to-weight ratio, and in this contest, bone is the clear winner. It's optimized for maximum durability with minimal mass. That's how we can walk, jump, and run without being weighed down by a heavy, clunky skeleton. It's a design that values efficiency as much as it values toughness. Let's dive deeper into that honeycomb structure. The internal sponge, or trabecular bone, spreads stress using a lattice pattern. When a force hits one point, it doesn't concentrate there. Instead, it redistributes across thousands of tiny struts, like a shock-absorbing network. Concrete lacks that internal cushioning. When stress concentrates on a single point in concrete, it cracks. Bone, on the other hand, diffuses the impact, protecting itself from damage. And here's the most incredible part. Bone is alive. When it fractures, specialized cells get to work and actually rebuild the damaged matrix. Your bones remodel constantly, responding to the stresses you put on them by becoming stronger where needed. Concrete does not self-repair. Once it cracks, it stays cracked unless it's repaired by humans. This ability to heal and adapt is something no man-made material can truly replicate. The design is also incredibly clever. Our long bones, like the femur, are hollow with marrow inside. That central cavity significantly reduces weight without compromising much strength. It's the same engineering principle aircraft designers use to build planes that are both strong and light enough to fly. Nature figured it out first. From an athlete sprinting down a track to a child running on the playground, our bones allow for dynamic movement under repeated loads. They act as shock absorbers, levers, and anchors for our muscles. Concrete is fantastic for supporting static weight, like in a building, but bones are designed to support a life in motion. Now, this doesn't mean bone is a better building material for everything. Concrete is excellent for massive structures like bridges and dams, where pure compressive strength is king. It's about different tools for different jobs. But for a living, moving, self-repairing system, the composite architecture of bone is simply superior. So next time you stand up, take a jump, or give someone a hug, take a moment to thank your amazing bones. They are stronger than concrete in all the ways that truly matter. They're lightweight, tough, and alive. If you enjoyed this dive into surprising science, be sure to subscribe for more. Thanks for watching.